Alright guys, this is the periodic table in reactivity notes. Also what's connected to these notes is the metals, metalloids, and alkali, metalloids, and non-metal notes as well. So you do have two sets of notes today, but these two sets of notes really go hand in hand. So that is why I combined it to one PowerPoint. So let's get started. So, I took a picture of the notes I did for this PowerPoint. It should look like this. Remember, you have your Cornell notes, the title. I put the title on the side just so I can fit the essential questions in that space up top. Periodic table, that is TEKS 8.5C. So make sure you write that down. Make sure you draw your squigglies or fold your paper in or draw a straight line. You don't need that much space because there's not that many questions. Obviously, I put like metals, non-metals, and stuff like that in those columns. Again, you need highlighters or you need color pens, just like I did my notes. I did my notes so I know how long it takes. And your notes should look something like this. So your notes, sorry, this is messy. Alright, so if you want a stamp on your notes, they need to have all the information down. Okay, when you guys get to college, literally the classes are called lectures. And that means all you're doing is listening to the professor talk and you're writing notes down. Some lectures allow laptops, some don't. So you need to know how to take good notes because that's all you're going to have. There's not going to be worksheets. There's not going to be any types of stuff like that. So these notes took 4 pages. So there's 1. There's kind of 2. There's 3. And then on the next slide, that's 4. So I guess 3 total if you didn't count that interactive notebook page. So make sure taking good notes and you're paying attention because a lot of your quizzes are going to be open note quizzes. Alright, your essential questions that you need to write down. How do valence electrons determine an atom's chemical properties, including reactivity? How are elements classified on the periodic table? So we're going to start with the atom. Alright, ignore that little square on that top right corner. But go ahead, we're going to start with the atom. Just like a little review from past notes, it's the basic unit of an element. It consists of 3 parts, protons, neutrons, and electrons. And the atomic mass is the sum of protons and neutrons. Go ahead and pause here if you are still writing. Remember, I'm highlighting stuff for a reason, so make sure you're highlighting that stuff or using a different color or underlining. So our electrons are our negatively charged subatomic particles. They are located outside the nucleus. So that is our electrons right there. Go ahead and pause here if you're still writing. Alright, so valence electrons, that's a new term, so make sure you're highlighting that. It's an electron in one of the outer shells of an atom that can participate in forming chemical bonds with another atom. So it's one of the outer shells of an atom and it can participate in forming chemical bonds with other atoms. The number of valence electrons determines the element's reactivity. Go ahead and pause here if you are still writing. Alright, so the periodic table arranges all of the known elements in order of increasing atomic number. So that number of protons. So remember that atomic number is that number above the symbol. And that means the number of protons, in increasing, it's going up. So it's going up every time you're going right and down. Order generally coincides with increasing atomic mass. So I'm going to choose a different color. That atomic mass is that number on the bottom. So I'm underlining it. And it says generally, if you're looking at the periodic table, sometimes the number is going to be a little bit smaller. But for the most part, the atomic mass is going to increase too when you go right and down. Go ahead and pause here so you can get all this information down. Alright, so there's no template that we printed out for this slide. I just want to make sure that you have this information written down, so you can just draw a box and you're going to label what is the atomic number, what is the symbol, and what is the name, and what is the mass. Pause here so you can do this and then fill in these blanks to the best of your ability. Alright, so once you have it filled in, you should have the 14 be the atomic number. The SI is the symbol. 28.086 is the atomic mass. And silicon is the element. Just kind of a refresher from last set of notes, the atomic number is also the number of protons. The symbol is SI. The atomic mass is 28.0086. And the element name, silicon. Alright, so periodic table. Everything in blue, so make sure that you write all this information down. Everything in blue in the periodic table is going to be your metals. So on the interactive notebook page you need to find a blue marker, crayon, pencil, and you're going to make sure that you color in all the blue. Alright, metals are solid at room temperature. They have a shiny luster. They're ductile, which means they bend into a wire. They're malleable, so they can be hammered. They're a good conductor of heat and electricity. They have a high density, a high melting point, and reactivity. So those metals at the bottom corner the bottom left corner are the most reactive. Go ahead and pause here if you're still writing. Alright, everything you see in red, change that. Everything you see in red is the nonmetals. Okay, they are dull in appearance, they're a poor conductor of heat and electricity, they are brittle, so that means they break easily, they're not ductile, they're not malleable, they have low density, a low melting point, and they're less reactive. go ahead and write that information down. You can pause it right now. All right, your metalloids are going to be everything that is in green. So basically everything on both sides of the staircase. Elements on both sides of the zigzag line or the staircase have properties of both metals and nonmetals. So they share properties of both. Go ahead and pause here if you're still writing. All right, so for this page, I want you to write all the metals, nonmetal and metalloid down. I basically want you to write it down like this. I want you to work with a partner. On the notes you just written down, I want you to determine what is a metal, a nonmetal, and a metalloid. So for example, you can either draw a line or you can write the number. So whatever works best for you, that's what you're going to do. So again, draw a line or write the number next to it. Go ahead, work with the partner that is working on the notes at the lab table with you. So on the other side of this template, I want you to answer these questions to the best of your ability, and you're going to keep this with, or look at this while on the next few slides to help you answer these questions. All right, so in your interactive notebook and using this template, you are going to circle the groups. So circle the groups, which is number 1, in green. So your groups go down, and make sure you label that. And you're going to circle period 2 on the periodic table in red. So you have your groups, and then make sure you're doing this part in red. So go ahead and pause now if you're still doing it. Okay. So the periods on the periodic table are the rows numbered 1 through 7. So on the side of your interactive notebook, you have little numbers. Right here for me is the arrows. That is your periods, and they are going to be in rows. So they're going to go across. And when you think rows, you can think movie theater. So when you're in your when you're at the movie theater and you're at the lounge movie theaters, it goes by rows. So it kind of goes across, like that's your row 1, 2, 3. Obviously the numbers are a little bit backwards. So it's going to be 1, 2, 3. And you have 7 rows. And those are your periods. The atomic number is going to increase from left to right. So we talked about that. You have hydrogen is 1, you have helium is 2. It's increasing from left to right. And then you're going to go down each time. Those in the same period have the same number of energy levels or shells. So that is something you should highlight. Those in the same period. So you have your first period, second period, third period, fourth period, fifth period, sixth period, seventh period. Same number of energy levels. The chemical properties are not all similar. If you look at level 4, or period 4, it goes from metals, which are like in the purple right now, and then it goes to, in that period 4, it goes to like non-metals, and then it goes to, or non-metals, and you have your noble gases and stuff like that. So they're not going to have the same chemical properties. All right, go ahead, hit the next slide. So your groups. Groups on the periodic table. If you look at the arrows, your groups are going to go down. It's numbered 1 through 18. So these are your groups 1 through 18. When you think of groups, so G stands for going down to the ground. So the arrows are going down to the ground. Those are your groups. In the groups, they have the same number of valence electrons. Chemical properties in groups are similar. Group 1 is going to be the most reactive, and group 18 is going to be the most inert or stable. So make sure you write that down in your interactive notebook. And make sure you're labeling your periodic table, because I know this is a lot of information to remember. So you have your reactive, and then you have your stable on that side. And then you can draw an arrow. Alright, it cut me off on the bottom there. Once you finish labeling, you can go to the next slide. So all the information that you just completed on the periodic table should be done here. And then you should be able to answer these questions now. Okay. All right, moving down the period, so rows 1 through 7, this is the stuff I told you to write down. Increasing energy and reactivity. So moving down the period, rows 1 through 7, the number of energy levels or shells increase by 1. So elements in period 3 have 3 orbitals. Elements in period 7 have 7 orbitals. So make sure you write that down. Moving down the period increases the reactivity. All right. So lithium is going to be less reactive than sodium. So your example for that is going to be over here. You have lithium in period 2. It increases the reactivity as you go down. So sodium is below it, so the reactivity is going to increase. Make sure that you draw a down arrow next to period 1 through 7 and put the words increasing energy and reactivity. When you're done with that, go ahead and click to the next slide. Or you guys aren't clicking, just go ahead and push play. Alright, so now we're going to talk about the trends in the groups. Groups, you have your columns 1 through 18. So your groups, remember, go down. Valence electrons are the electrons in the outer energy level, so the outer shell. So when you're drawing your nucleus and your electron cloud, that's the outer shell. Group 1A has 1 valence electron. Group 5A has 5 valence electrons. So make sure you copy that part down in your notes. Go ahead and pause here if you are still writing. Okay, reactivity increases as you move from left to right, or when you move right to left. across the metals, and then left to right across the non-metals. So right here, or let me just do that once. I would write increasing reactivity right there because that is where your nonmetals and your metals meet. So make sure that you draw those arrows to represent that the reactivity is increasing as you go to the left or to the right. Go ahead and pause here if you're still working on that. Alright, so your reactivity of atoms, the ability of atoms to combine or separate with other atoms and create new substances requires a chemical reaction. Valence electrons are the key to this process. So those valence electrons are the electrons on the outer shell. Reactivity changes across the periodic table. Pause here if you're still working on that. Alright, I'd make sure I write that question on that side column of your Cornell notes. What makes an atom happy? Or, in other words, stable? Having its outer shell or outer energy level filled with electrons makes it stable. Example, group 18, which is highlighted in red. These atoms do not want to bond with other atoms. They want to be inert. Helium is the exception because it is happy. It is a stable element with only 2 valence electrons. Go ahead and pause here if you're still writing. All right. What happens if an atom doesn't have 8 valence electrons? Hydrogen has only 1 valence electron because it's in group 1. It does not follow the rule of 8, but its happy number is 2. So right now it is not happy because it only has 1. Who might hydrogen bond with to make itself happy and make itself stable? Hydrogen easily bonds with itself. Since hydrogen has, we'll go back really quick. Since hydrogen has 1 electron, to have that happy number 2, it's going to bond with itself. This way both hydrogen atoms can share an electron and be happy or stable. Alright, let's look at oxygen. Oxygen has 6 valence electrons. It's in group 16. It needs to bond with 1 atom that either has 2 valence electrons, or it can bond with 2 atoms that have 1 valence electron. So, I want you to remember that that happy number is 8. That goal is to get, even though it has 8 electrons total, you need 8 valence electron total to be happy. So what element did we just talk about that has 1 valence electron? All right, so hydrogen. So it combined with 2 hydrogen electrons. Those 6 valence electrons, they just kind of moved up a little bit. Let me undo that. Just moved up a little bit, and it combined it with the hydrogen. So now it has 8 total, and that makes it happy, and that makes it stable. And it created a water molecule. Sometimes this water molecule is called the Mickey Mouse molecule. Go ahead and pause here if you're drawing this, which you should be, and you should be writing this down. Alright, so for your summary, I want you to identify that valence electrons determine an atom's chemical properties, including reactivity. And then I want you to interpret the arrangement of the periodic table to explain how properties are used to classify elements, including periods and groups. So go ahead and do that. Once you answer that question, you're going to move on to the next set of notes, so the metals, metalloids, and the nonmetals. So go ahead and pause here, answer your question, and then this video will continue. Alright, so metals, nonmetals, and metalloids. So again, I combined the PowerPoints just because these two really work together. This is the notes that I took. I think it was just these 2 pages. I think the other page is just another cutout of the interactive notebook template. So there's another template that you're going to cut out. If you look at this page, I have, let me do this in a different one. Physical properties, and then you have your physical properties all written down. And then I'm talking about metals, metal examples, and that's it for metals. And then nonmetals, that's it for nonmetals. And then I have my metalloids. So, quick set of notes. We're just going over the properties and stuff like that so you understand it. So your essential questions: what are metals, nonmetals, and metalloids? How are physical properties used to compare metals, nonmetals, and metalloids? Go ahead and pause here if you're still writing. Alright, so physical properties can be observed or measured without changing the composition of matter. So solid, liquid, and ice, blue, melting, so those are your physical properties. It's used to observe and describe matter, including the following: appearance, texture, color, odor, density, luster, conductivity, malleability, and ductility. Go ahead and pause here if you're still writing this down. Alright, so those physical properties. Luster. I would highlight luster. It refers to the way a metal's surface reflects to light. So is it going to be shiny or dull? Pause here if you're still writing. Alright, ductile refers to the way most metals can be stretched into wires. So highlight ductile, write the definition down. Pause here if you're still writing. Malleable refers to the way most metals can be hammered or rolled into thin sheets. Highlight malleable, pause here if you're still writing. Brittle, tendency of a material to fracture or fail with a small amount of force. Example, glass, silicon, or chalk. Pause if you're still writing that. Make sure you highlight brittle, write the examples down. Conductivity is the measure of the ease at which an electric charge or heat can pass through a material. Go ahead and pause here if you're still writing. Insulator, so material that keeps energy such as electricity, heat, or cold from easily transferring through. Alright, so you're going to cut out this template that you've received. You're going to paste it. Make sure that you are pasting just this highlighted part. So that's the part you're going to fold and you're going to glue down. You're going to color in the metals, nonmetals, and metalloids as they are being discussed. Alright, so most metals, or most elements, are metals. There's 88 elements to the left of the stair step line, most are solid at room temperature. So physical properties of metals. So they're going to be shiny, so they're going to have good luster. They're going to be good conductors of heat and electricity. They're going to have a high density, so they're going to be heavy for their size. They're also going to have a high melting point, and they're going to be ductile. So most metals can be drawn out into thin wires. It's also going to be malleable, so most metals can be hammered into thin sheets, like aluminum foil. Go ahead and pause here if you're still writing the physical properties of metals. Metal uses. Copper is used for electric wiring. Coins. They don't make coins out of copper anymore. I think they stopped doing that in like 1982. Now it's, I think, made out of zinc with a copper foil around it. Gold. So jewelry, fillings. Fillings is another thing that they don't use gold for anymore. Lithium is used for medicine and batteries. And then you can kind of think, what are some other uses of metal? So then you have your nonmetals. So nonmetals are found to the right of the stair step. Their properties are opposite of metals, and most are gas at room temperature. So pause there if you're still writing. So physical properties of nonmetals: there's no luster, so it's going to have a dull appearance. Poor conductor of heat and electricity. It's going to be brittle, so it's going to break pretty easily. Not ductile, not malleable, low density, and a low melting point. Non-metal uses: oxygen, so they use oxygen for rocket fuel. They also have oxygen to help support life, so they have the oxygen tanks, and they have the nasal cannulas and stuff like that. You have your chlorine, so the chlorine, they use that for water purification, and chlorine's also made out of PVC pipes. Helium is used for balloons as well as a coolant. Alright, so your metalloids. Your metalloids are elements on both sides of the zigzag line. So it's going to be the elements you see in gray. So I would, with that interactive notebook, draw, or with that template, draw that out. Make sure that you're coloring in all the stuff that you see in gray and labeling that as metalloids. Something to write down and to highlight, since you do get the periodic table on the test, just not labeled. Something to help you label the periodic table is to remember boron. The moron is at the top of the stupid stairs. So that boron is going to be the top of the stairs. So that's something to help you remember where the stairs starts. Make sure you write that down and you highlight it. Alright, so physical properties of the metalloids. They share properties of both metals and nonmetals. So they're solids, they can be shiny or dull, ductile, malleable, conduct heat and electricity better than nonmetals, but not as well as metals. Metalloid uses. So boron is heat-resistant alloys. And it's also the green color in fireworks. Silicon can be used for glass and semiconductors. Arsenic is used for poison and color in fireworks. And that is it. So make sure that you answer these questions. Identify metals. Can you do that? Nonmetals and metalloids on the periodic table. So basically, if I were to give you an empty periodic table, can you highlight the metals, nonmetals, and metalloids? Make sure that you can do that, so I'd make sure that you're practicing. And can you compare metals, nonmetals, and metalloids using their physical properties? So answer those two questions, and then you are done with the notes. Make sure that you get a stamp from me So it's going to go on your checklist. If you don't get a stamp, that means your notes were not completed to my standard. So make sure that you are going back, highlighting, filling in stuff that you didn't fill out that you thought you could skip over. All right, that is it.